Hey everyone, in this video I'm going to walk you through some of the parts of my ESP32 dash code. I didn't go into that much detail last video on the code side of things, so this is just going to be more detail oriented, deep walkthrough of the code. Let's jump in. Alright, so first up here we're just doing a bit of setup with these variables at the top, declaring which pins we want to use. Now these pins actually do matter on ESP32 devices. There's certain analog style pins that you can have voltage go into that read a lot better than others. So these pins were picked because they're ADC compatible inputs, meaning they can read analog voltages but can't output PWM or digital signals. And the reason why that's perfect for the sensors that we're using, like oil pressure, coolant temp, etc., is that these pins are part of ADC1 on the ESP32. The reason that matters is ADC2 gets disabled when Wi-Fi is active. So using ADC1 pins like 32, 33, 34 keeps everything reliable even when Wi-Fi is used. If you put one of these sensors on a pin that is ADC2 and you have Wi-Fi on, you get really inaccurate readings, and it's just all over the place. So this just helps keep random noise or anything down. Next up, what we're doing is we're doing a bunch of calibration values. So these are per sensor. So whatever sensor you have, you want to put in these. You just basically, an ideal world, you'd have an oil pressure set up with some sort of compressed air gauge or something into the end where you know it has a fixed value of pressure, and then take a reading of what that sensor's voltage is when it's at maximum pressure, like 150 psi, and at lowest pressure at 0. And that's what you want to do here, and set all these values accordingly. And it's the same story for fuel sensor as well, and fuel level. You want to, right here what we have is a voltage map sort of thing. So when the fuel gauge is reading 0.6 volts, that's equating to 100% fuel. And when it goes down to 0, we're at 0.05 volts, or 0 volts is that. Next, we just have a bunch of other stuff for just smoothing and making it so that, you know, when you go up a hill, your fuel gauge doesn't just drop completely, even though you still have fuel in the tank, and vice versa. Going ahead to the functions now. First up is map float. So pretty much this takes a value from one range and scales it to another. It can map a voltage between 0 and 3 volts into a pressure range from 0 to 130 psi kind of thing. Just makes it a lot easier to scale. Next up we have this method, which pretty much just keeps readings stable by ignoring small changes. There's a threshold you can mess with here. You can put whatever threshold in. This just helps keep the noise down again, because there is a lot of noise we have to filter through. Next up, this method here is for turning your fuel sender's voltage into fuel percentage. So, and then it calculates a smooth value between them, because we only have 4 points on the map. We want to interpolate between the values that we have. That way we don't have to go through and for each decimal place have a known value and have a table that's over 100 characters long or 100 length, right? So this is just a nice method for that. Read smooth analogs. It samples the analog pin multiple times and then sorts the results. So it's a median filter going on here. Again, this method is pretty much just helping filter out noise and spikes from any readings that we get. Next, we have a little struct just to help keep things all nice and organized in here. Update demo data. You don't really have to worry about this one. This is more just you can send a different serial command and it will cycle through the LCD's values just so you get an idea of what it will look like when everything's hooked up. This method simply just keeps a rolling average of your fuel to help smooth it out, and like I said before, with the hills and vice versa. Update dashboard data is the main kind of flow. It reads all 3 sensors, converts their voltages into real units, applies the smoothing that was up above, and then it saves it all into this data structure that we have above as well. Stores the oil pressure, water temp, and fuel. You can see here now we're using all the helper methods that we had above, such as map float, analog read, interpolate fuel percent, update rolling fuel average. All that's coming together now here in this main method so that we can actually update our data structure and then use that value elsewhere. And where we're using it elsewhere is with right-centered and display to LCD. So these two kind of go hand in hand. Pretty much right-centered prints neatly and centers it in each row. That way it's not just to the left or to the right or just randomly on the screen. It makes it nice and centered. And then display to LCD is what actually takes the values that we got earlier, the dash data, and then puts it onto the LCD screen. So we're taking also that data, seeing if it's above a certain threshold or below a certain threshold, and that's where our warning system kicks in, where at the bottom it'll flash temp too high or oil pressure low, as you can see here. And that also has a blink state as well, because this display to LCD method is called in a loop. But this method is always being called. It takes all the values that we have above with update dashboard data, which is also always being called. It's just displaying it. So we're taking all the values that we got earlier, adding some text to it using our right-centered method, and then displaying it on the LCD right here. The warning logic, I think, is a nice touch because it just makes a nice little blinking alert that when you're not always looking at the screen, you can see something in the corner of your eye starts blinking. Oh, must be a problem, right? So that's what we have going on here. It's just a simple Boolean value that has a little blink animation on it. Next up, we have our handle serial. This is mainly just for that demo mode. We don't have anything else going on with the serial inputs or anything. We're just taking a serial input and seeing if it's demo on or demo off. And that's it, because there's nothing else really on the serial to mess with. And that's how the ESP32 dashboard code works. Hopefully I went in depth enough. Everything is relatively simple in this script. It's pretty much the only advanced part, if you want to put it that way, is taking the voltages and mapping it to a percentage and all the smoothing logic that goes on. The smoothing logic is probably the meat and potatoes of this script. But you can take it yourself, adjust whatever values you need for whatever your sensor's output is, thresholds, update rate, depending on what screen you're using. You can modify this as well. Hopefully I went through it enough and made it simple enough to understand. That way you can use it in a project of your own.